Hi everyone, my name is Adova, co-founder of Panaptico, where we provide AI and agent-driven solutions for managing and automating compute clusters within an organization's machine learning and data infrastructure, starting with Databricks, GCP TPUs, AWS TRN1 and TRN2. So right now we have our integration with Databricks here that we at Panaptico use. We have 4 workspaces, 1 at AWS and 3 at GCP. So getting started, you just see an overview of your clusters. We're running 2 on GCP right now, so you can get just like a brief overview of like what's going on, sort of just like the overview of these clusters, make quick changes, and like whatever. One of the things that we do is the metrics that are very well defined. So we'll start with something like network metrics, but these are very well defined for exactly what you would want to see how your data and AI workloads are performing. So for this cluster here, we can see like latency, performance index. You can find out congestion status. You can see like what it means when we say it's good, when it's normal, there's no congestion, set up latency, and other just like very well defined metrics that is purposely built for you're doing data and machine learning workloads specifically. If we go to the health metrics again, this provides insights into like how healthy are your clusters doing, in terms of like this usage, stability score, how long a task taken to like take, how much are you wasting resources on, what's your health entropy, and things of that nature. What we've also been able to do is we've also been able to use Databricks Genie to create something called Health Assistant through all these metrics here, where you can basically query query your clusters into getting more details, like what's the overall health of my cluster, what's causing high memory usage, analyze potential performance bottlenecks, recommend optimizations for my cluster, and this is AI driven, powered by Databricks Genie, which will give you the insights that you're looking for in your cluster. Another one that we'll look into here is Logs Analyzer, and this one's going to take just a little bit to load up, but this gets you more detailed insights into like what's going on in your logs. And what we've done with this is we've provided a queryable system in here. So these are your logs, and you have a lot of views in here. You can view errors only warnings, driver logs, executor logs by like time range. You can also view this thing we created called analysis view, where you might want to highlight things like, okay, what are the top 3 errors that we found? What are the top warnings that we found in this cluster based on like the logs? And if you go to like the live view here, of course you can see like your logs and things like that. And what we've also done is we've also provided a way where you can understand what's going on in your system with AI. And you can, so if I click on this log here, I'm trying to understand with the AI, it tells you, this is what this log means. And of course you can follow it up as well. And this one is provided with the integration that we have with Anthropic, with Genie as well on the system. The other thing that we've been able to do is cluster agents on the system, which is probably our most important feature. And I'll just go to a different screen here, but we provided cluster agents on compute pricing, compute security, and so this is the entire system of logs that we've built here. So your compute agents, your Spark agents, your reliability agents, performance optimization, cost, compliance, security, and metrics agents. So today we've launched with the compute agents in general. It allows you to like understand, make schedules on tasks, everything around your compute infrastructure that you can do. For example, you can say, hey, I want to deploy a cluster with SSD storage above 100 gigabytes encrypted with N1 family. So if I click on this, so you would need to just authenticate, and you can authenticate with all these providers, so your Databricks secrets. So we have Databricks secrets authenticated right now, so we'll just do that. And I will click on this again and hit send. And what this will do is the agent is going to figure out, okay, your question is you want to deploy a cluster with SSD storage above 100 gigabytes encrypted with N1 family. And so it creates a session. It's an agentic session that allows you, and just while that's loading, you can also schedule tasks on the platform to say, hey, create a cluster at 3 p.m. tomorrow, downscale it to whatever, 2 minimum workers, 3 minimum workers at 12 p.m. That's when we have minimal workloads. Do this every single day, and then at maybe 8 a.m. the next day, upscale it again to whatever you think is right for you. So that query I set with, hey, deploy a cluster with SSD storage above 100 gigabytes encrypted with N1 family, Based on the available node types, the following N1 family instances meet your requirements for storage. And so what it's basically doing here is that it's looking at your entire Databricks infrastructure. It's looking at what you have quotas for. It's looking for whatever meets your requirements. So all these are above like 100 gigabytes SSD. It has, it's a cluster again. It's the N1 family. And you can also follow up with this. So I might want to say, I want the ones that are optimized for machine learning workloads. Again, what it starts to do again is it starts to think about your infrastructure. You want something that's optimized for machine learning workloads. It wants once again that the SSD. So now it's sort of minimized like the entire. So this is the memory optimized one. These are the general optimized one, and it sort of gives you a brief brief summary of what this means. And if I say, okay, I understand. Now I want to deploy a cluster called ETL cluster. I like N1 standard -4. Could you deploy it with your recommended settings? And I'm going to have a caveat here and say I also want it to be cheap as well. And the job that I do want to run on this cluster is going to take, I think, just 45 minutes. Again, the agent starts to like look at all your requirements. It wants a cluster called ETL cluster. It might think, okay, the purpose of this cluster is to like run ETL workloads. You like the node type that it's selected. You want its recommended settings based on that. You want it to be a cheap cluster, so not too expensive. So it gives you the recommendations. Here's the proposed configuration of the cluster that you want to run. Cluster name is ETL cluster. Driver node type is this. Worker node type, and all of this. So I'm going to say yes. I like this configuration. Would you please put it? And just before I say that, I'm going to open up our Databricks infrastructure just so that we can see it in real time when it actually does deploy the cluster. So you can see right now that we are running just 2 clusters. I'm going to say yes. Would you please deploy it? Yeah. So it's currently being deployed, and if we go back, we should see a 3rd cluster being deployed right now. And so you can also schedule tasks, as I mentioned as well. You can see some of the tasks that we've scheduled. A few of these have failed for various reasons. You can see the reasons why they failed as well. You can say, hey, notify me when this. You can also like edit the tasks as well for whatever changes you want to do. You can make the tasks sort of in phases. So do this, set up a cluster at 6:30 p.m. tomorrow. Run this job. This job should run this notebook. Alert me if this job fails. If this job fails, retry it a couple times. And if it does fail, figure out the reason why it fails and actually fix the job. And then continue to like redeploy the job as well. And you also have sessions as well, so you can keep up with the many sessions that you have. You can come back to this at any time. It keeps the memory intact as well for if you want to like continue a conversation, if you want to continue a task that an agent has. And you can also have ticketing. So for this, I can say, okay, I've deployed a cluster. Make sure it goes to like our Jira, our Linea, our DevOps, whatever thing you want, and it would also just like be connected with that. So this is what Panaptico is. The entire purpose of this is to make sure that DevOps engineers, your engineers, your data scientists, your ML engineers, everyone who deals with compute clusters, because that's central to what data and machine learning is today, can use this and run their jobs, run their workloads without minimal friction. Thank you.